We are moving to another lesson, and the topic of this lesson is cosine rule and its applications to bearing and distance and solving triangles. Now, to generate this cosine rule, we have to make use of a triangle which is not a right angle triangle, and we are considering this triangle ABC. I explained in previous lessons that the side facing each angle is represented using the lowercase or the small letter. We have angle A. The side facing angle A, we are representing that with small a. The same also for angle B and angle C. And cosine rule states that for a triangle ABC, we have a square, the square of this side, is equal to the square of the other two, the square of the second side plus the square of the third side, minus 2 multiplied by BC cos A. This one is in terms of A. It can also be stated as B square equals A square plus C square minus 2AC cos B, and this is stated in terms of B. And we have the third one stated in terms of C as C square equals A square plus B square minus 2AB, the product of these two, cos C. So that's the three that we have. The first one being in terms of A, second one in terms of B, and third one in terms of C. We can also represent the triangle using 3 different alphabets apart from ABC. If you have them as X, Y, Z, where we have A, that will be X, where we have B, that will be Y, where we have C, that will be Z. So we do that also A minus 2X, A minus 2YZ cos X. That is if you have X, Y, and Z. Also, if you have it in terms of P, Q, and R, where we have A, P will come in, where we have B, Q will come in, and where we have C, R will come in. Then we have the 3. Also, for calculating angles, this formula can also be used for calculating angles, and we are able to derive these 3 from this formula. From the first one, if you want to make cos A the subject of the formula, we have to move these 2. We have to move this to the other side, then A will come in. Then we have that as cos A is equal to B square plus C square. By bringing A square in, that will be minus A square divided by 2BC, which is the coefficient of cos A that we are having A. And that's why we have our denominator A to be 2BC. The second one too, by making cos B the subject of the formula, we have cos B equals A square plus C square minus B square. By the time we transfer B square to the other side, it will become minus. Then divided by the coefficient of cos B, which is 2AC. And we have our denominator as 2AC. Then moving to the third one, we have cos C is equal to A square plus B square. Then by moving this one to the other side, that will become minus C square. And our denominator is 2AB. That is the coefficient of cos C. So these 3 can be used to find sides, but these 3A can be used to find angles. So when we want to find side A, we make use of this. But if we were asked to find the value of angle A, we make use of this. And when we have our value, we now take arc cos of the value we have here, and that will give us the value of angle A. If you are asked to find side B, we make use of this. But if you are asked to find angle B, then we make use of this. We put the value of A, value of C, value of B, then you will simplify. Then the result we have to find angle B, we now take the arc cos, which is the inverse of the cosine of the value we have. That is what will give us the value of angle B. Then if you are asked to find angle C, we make use of this. But if you are asked to find side C, we make use of this. But if you are to find angle C, we make use of this. Then by simplifying this, we now take the arc cos or the inverse of the cos of the value we have, and that will give us angle C. I said it earlier that sine rule can be used when we have two sides and the angle facing one of them, or when we have two angles and any side. Now that is not the same for cosine rule. We can make use of cosine rule when we have two sides and the angle between them. So when we have a triangle like this, for instance, and we have this side as maybe 7 and this side as 5, we must know this angle to use cosine rule. That is what the first condition is saying, that we must have two sides and the angle between them. But for sine rule, we have two sides and an angle facing one of them. And if you look at this triangle here, the angle is not facing 7 or 5. It is facing the unknown side. And secondly, we can use cosine rule when we know all the three sides and we don't have any angle. Like for instance, if this one is 4, now we know the three sides, we don't know the angles. So for this one, we have to make use of cosine rule, and the type of cosine rule that we use is this set of second cosine rule that I gave for finding angles. So this will lead us to examples. We have the first example to verify this cosine rule. The first one, it says find the value of the side opposite the angle in the diagram in the triangle below. And this is the angle we are given, 49 degrees. The side facing that angle is small a, because the angle we are given is angle A, which is capital A, as 49 degrees. We are given side B, we are given side C. And if you look at the triangle very well, we notice that we are given two sides and the angle between them, which is the first condition for using cosine rule. So from here, we first state the rule we are using cosine rule. If we want to use a rule, it is very important for us to state the rule that we are using. If it is sine rule we want to use, we state it that using sine rule. And what does that sine rule says? Then from here, cosine rule, since it is the one we are using, we state it, we have a square. Since a square is the side we are asked to calculate, we state it in terms of a. So we have a square is equal to b square plus c square minus 2bc cos a. If you have to calculate b, we use the other one, which is in terms of b. So from here, a square, our b is 3, we have 3 square, our c is 5 square, minus 2 into 3 multiplied by 5, then cos 49. A square, 3 square is 3 multiplied by 3, which is 9. Then 5 square is 5 multiplied by 5, and that is 25. Then minus 2 into 3 multiplied by 5 will give us 15. Then cos 49 degrees. From there we have a square, the addition of 9 and 25 is 34, minus 30 cos 49. We should take note of something here. 34 is on its own. Then this 30 cos 49, they are together. Don't make the mistake of removing 30 from 34. If you should do that, you end up getting a wrong answer. 34 should be treated separately. Then this 30 cos 49 should be treated separately. And then we use the sign that is separating them. Then from there we have a square equals 34 minus 30. From our 4-figure table, cos 49, that is, you go to cosine and you check 49 under 0. So by doing that, we have 0.6561. So a square will be 34 minus, so 30 multiplied by 0.6561 will give us 19.68. So from this stage, we can now use the subtraction sign. Then we have a squared to be 14.32. Now since a squared is equal to this, to generate a, what we do is we take the square root of both sides. For any expression that involves square, we take square root. For any expression that involves square root, we take square to get what we need from that expression. So from here, taking square root, of both sides, we have square root of a square equals square root of 14.32. Square, we cancel square root, then a will give us 3.78 centimeters from the calculator. And that gives the side that we are to calculate, which is the side facing the angle that we are given. We don't need to stress ourselves calculating all the angles, because the question is not asking us to solve the triangle completely. It is only when the question is asking us to solve the triangle completely that we need to find all the angles. From here, we are given two sides, and the question is only asking us to find the third one. So we've calculated that, and that is the end of the solution to that question. Now we have another example which says we should calculate the value of b, given that angle b is equal to 120 degrees, side A is equal to 7 centimeters, and side C is equal to 12 centimeters. Looking at this angle b, it is more than 90 degrees. And when we have an angle that is more than 90 degrees, we call it obtuse angle. It is also less than 180. Or we can also say it is an angle from second quadrant. And from the triangle that we have here, I extended that angle beyond 90 because 120 is more than 90 degrees. So from here we have to calculate the side, which is side B, and that is the side facing the angle B that we are given. And looking at the triangle again, we have these two sides, and 120 degrees is between them. And that is from the first condition for using cosine rule, when we are given two sides and the angle between them. So the first thing we do is we state the rule that we are using cosine rule. And that cosine rule that we use this time around will be in terms of b, since we are to calculate b. So we have b squared equals a squared plus c squared minus 2ac cos b. So the value of a from A is 7. That is 7 squared. The value of c is 12. 12 squared minus 2 into 7 multiplied by 12, then cos 120 degrees. From here, we have the square of 7 is 7 multiplied by 7, which will give us 49. Square of 12, that is 12 multiplied by 12. That will give us 144 minus 2 into 7 multiplied by 12 will give us 84. Now, there's something we need to do from here. 120 is from second quadrant, and we need to revisit our quadrant. First quadrant, that is all are positive. Second quadrant, only sign is positive. So if only sign should be positive in the second quadrant, that means cosine and tangent, they are negative. So that from there we introduce minus because of this cos that we're having here, and because 120 from the second quadrant is negative, that's where this minus is coming from. So that is minus cos 180 degree minus 120. So from there, by the time we add this, we have 193 minus the product of 2 and 84, that is minus 168 into minus cos 180 minus 120 will give us 60. So from there we have, I explained this from the first example, that we cannot subtract 168 from 193. It will end up giving us wrong answer if we should do that. 193, we obtained it from the addition of a square plus c square. A square plus c square, they are on their own. Then minus 2ac cos b, they are also on their own. We do this one separately, we do the other one too separately. Then we use the sign that is separating them. So this is 193 minus 168 into minus, if you check cos 60 from our 4-figure table, that is cosine of 60 under 0. That will give us 0.5000. And from there we have b square is equal to 198. Now from here we have minus, we want to open that bracket, and when we are opening the bracket we make use of multiplication. So the product of minus and minus, minus times minus, that is plus. So this sign we change to plus, and the product of 168 and 0.5 will give us 84. So which means from here we have b square, the addition of 84 and 198 will give us 200, and from here this one will be 2, this will be 2, then 8 and 9, that will be 7, then this will be 2. We have 272. So b square is equal to 272. Now we are at the stage where we have an expression that is talking about square, and I explained it earlier that for any expression that involves square, we take square root. Sorry, this is 193. So this is 277. Then we take square root. Take square root of both sides. So by taking the square root of both sides, we have b square square root equals square root of 277. Square will cancel square root. Then from there we have b to be 16.6 centimeters. And even from this triangle, we can predict what our answer will look like. So that when we are solving and we have arrived at the wrong answer, we'll be able to trace our steps back. From this triangle, the longest side is AC, which we are representing with small b. And that is the side they are asking us to calculate from the question. If you are solving your own and your answer is less than this 12, then something is wrong with the steps. Your answer from the triangle, since this side is the longest, must be more than 12. So that is the end of the solution to that second example. We have another example, which is example 3. Earlier, I gave the two conditions for using cosine rule. The two examples I solved earlier talked about the first condition. Now this third example is talking about the second condition for using cosine rule, which is we are given the three sides with no angle. Now when we come across this, we have to make use of cosine rule. Sine rule cannot work here because we don't know any angle. So that's why we cannot use sine rule. The best thing to use here is cosine rule for finding angles. So from here, we can decide to find any angle first. We can decide to find angle A first. We can decide to find angle C first. We can decide to find angle B. So when we know two of the angles, we don't need to use cosine rule again for the third angle. We just use sum of angles in a triangle equals 180 degrees. So from here, using cosine rule, I want to find angle A first. Using cosine rule for A, from the cosine rule I gave, I said cos A is equal to b square plus c square minus a square divided by 2bc. That is what we are using. And from here we know what A is. B is 9, that is 9 square. C is 10 square. And A is 5, that is 5 square divided by 2 multiplied by b is 9, then c is 10. So from there we have cos A to be 9 square is 9 multiplied by 9, which is 81. 10 square is 10 multiplied by 10, which is 100. Then 5 square is 5 multiplied by 5, which is 25. Then for the denominator, 9 multiplied by 10 will give us 90. Then multiplied by 2, that will give us 180. Cos A is 181 minus 25 divided by 180. The steps are very important. That is why I'm trying to do them step by step. From here, I could have just find the square of 9 and square of 10. I will add them and remove 25 and I will move to this step. But this step is very important. That is to show that we know what the square of 9 is, we know what the square of 10 is, and we know what the square of 5 is, because mathematics is all about steps. When the examiners want to mark, they mark steps. The final answer at times may earn a student just a mark, but the steps, the whole question may be for 5 marks. The other steps will earn the student 4 marks. So by ignoring some steps, that is not okay. We have to show all the steps that are needed. So from here, cos A is equal to 156 over 180. So if we press our calculator for 156 over 180, then we have cos A to be 0.8667. So when we get to this stage, what we need is angle A. But we have cos A to be 0.667. And the next thing to do is to take arc cos of A. And we take arc cos by going to our 4-figure table to check for the nearest value to this 0.8667. And by doing that, we have A to be arc cos, which is the same thing as cos inverse of 0.8667. And from there, A is 29.9 degree. So that is 29 under 9. That is what is giving us the value that we have here, 0.8667. From the 4-figure table, we have been able to obtain it as 29.9 degree. We have obtained the value of angle A as 29.9 degrees. So we put that here. Now, the next thing to do, we can decide to find angle C first, and we can decide to find angle B. But now, I want to find B. After using this cosine rule to find B, then I will use sum of angles in a triangle to figure out the value of C. So using cosine rule, to find B, I will state the one for using formula in terms of B, the one for finding angles. So I have cos B equals A square plus C square minus B square divided by 2AC. So by substituting the values that we have here, we have cos B, A is 5, that is 5 square, C is 10, that is 10 square, minus B is 9, 9 square, divided by 2 multiplied by A is, we have A as 5, and we have C as 10. Now to the next step, we have cos B to be 5 square is 5 multiplied by 5. That will give us 25. 10 square is 10 multiplied by 10, which will give us 100. 9 square is 9 multiplied by 9, which will give us 81. Divided by 2 multiplied by 5 is 10. And 10 multiplied by 10 will give us 100. So from there we have cos B to be 125 minus 81 divided by 100. Then cos B is equal to 44 divided by 100. If you remove 81 from 125, we have 44. Then using our calculator, we have cos B to be 0.44. Now at this stage again, we need to go to our 4-figure table and we check for the closest value that will give us 0.44 from our 4-figure table, and that is called taking the arc cos. So B is arc cos of 0.44, or we can also call it cos inverse. So from there, B is 63.9 degree. That is, the closest value that will give us 0.44 is 63/9 from the 4-figure table. And we label that here as well. We have 63.9 degree. We already know what A is and we know what B is. There are two ways of getting C. We can decide to make use of that cosine rule, or we can also use sum of angles in the triangle. But to avoid too much stress, we just make use of that sum of angles in the triangle, since we already know what A and B, what they are. So from there, we have A plus B plus C equals 180 degree. The reason for that, sum of angles in a triangle. From there, A is 29.9, so we have 29.9 degree. B is 63.9, we have 63 plus 63.9 degree. And the one we are looking for, C plus C, is equal to 180 degree. And if you add this, we have 93.8 degree plus C equals 180 degree. And if you move this 93.8 degree to the other side, we have C to be 180 degree minus 93.8 degree. And therefore from there, we have C to be 86.2 degree. And with that, we know what A is, we know what B is, and finally we have the value of C to be 86.2 degree, and we have completely solved the triangle. We already know all the sides, and we know all the angles now. So the addition of these three angles, if you are doing yours, you must ensure that the addition of these angles is giving you 180 degree. We have another example which says, in a school, the church building is 300 meters due east of the assembly hall. Now, when we come to questions on bearing, we need to imagine that what they are talking about in the question is something that bearing is something around us, actually, but we need to try to get a picture of what that question is trying to talk about. We have a school, a church, and the assembly hall. The church is due east of the assembly hall. We assume that we have one like this, we have another one like this. Now, a classroom in that school as well is 200 meters on a bearing of 123 from the assembly hall. So we assume that that one is on another direction. Meanwhile, they've given us the bearing that it is on a bearing of 123 degree from that assembly hall. Now we have a question that how far is the classroom from the church? We have to get the distance between the classroom and the church. So we start by sketching the diagram. For the first statement, for the first part of the question, we have the church is due east. From our four cardinal points, we have this. This is north, south, west, then east. So we have, since the church is due east of the assembly hall, this is the assembly hall. I represent that one with A. Due east, we have this. This is the church. And the distance between them is 300 meters. This one is E, this is S, this is west, and this one is N. The same thing, this is north, south, this is east, and this is west. Now that classroom is 200 meters on a bearing of 123 from the assembly hall, that is from here. And this form of bearing is surveyor's bearing. And surveyor's bearing is to be taken from the north pole clockwisely. So we have this is 90, then we have 123. And another thing, the line we are using to represent, there is no examiner that will pick a ruler and start measuring 300 meters. But we must draw a diagram. From a diagram, the line we are using to represent 300 meters should be longer than the one we are using to represent 200 meters. So we can just stop that one here. Then we have this. So this is the classroom. Let me call that one R, room. I'm using R to represent it, but we can use any other alphabet which is different from A and C. So from there, this one is 200 meters, and the angle from this north pole to this line is 123. If the whole angle here should be 123, then what is this angle? Angle A is equal to, from A to A is 90. So the remaining one that we are having left will be 123 degree minus 90 degree, and that is 33 degree. So this angle is 33 degree. And this has resulted to a triangle where we have two sides and the angle between them. And that is the first condition for using cosine rule. We must have two sides and the angle between them. So from here we stated that using cosine rule, the side that is facing each angle, we represent them with the small letter. So this is R, this one will be small r, that is angle C, this one will be small c, this is angle A, and this one will be small a. The question is asking us to calculate the distance from the church to the classroom, that is small a, that we are having there. So we state our cosine rule in terms of a square is equal to c square plus r square minus 2cr, then cos A. From there, by substituting the values of cr and the value of that angle A, we have a square equals 200 square plus 300 square minus 2 into 200 multiplied by 300 cos 33 degree. So from there we have A to be 40,000. A is 40,000 plus 90,000 minus 2 into 60,000, then cos 33 degree. A square will be, the addition of this will give us 130,000 minus this one will give us 120,000, then cos 33 is 0.8387. So I will explain this again. We cannot subtract 120,000 from 130,000 because they are not together. 130,000, we obtain it from the addition of c square and r square. C square and r square, they are separate, and this one, they are together, the three of them, and from these three we are able to generate this. So we do this one separately, do this one too separately, then we now combine them together with the sign that is separating them. So we have a square to be 130,000. The product of these two will give us 100,640.47. And if you remove this one from this, we have a square to be 29,359.53. And from this stage, the next thing to do is to take the square root of both sides, since the expression involves square. So by taking the square root of both sides, we have square root of a square equals square root of 29,359 359.53. This square will cancel the square root and we have A to be 171.34 meters. Therefore, the classroom is 171.34 meters from the church. Now we have another example on application of cosine rule to bearing and distance. And the question says three towns x, y, and z are situated such that the distance between x and y, that is xy, is 60 kilometers, and the distance between x and z, that is xz, is 100 kilometers. The bearing of y from x, that from is very important. We have to take it from x, not from y, is 060 degree. And the meaning of this 060 is that the bearing is a surveyor's bearing. And the bearing of z from x is 290 degree. This one too is also a surveyor's bearing. And we have to calculate A, the distance yz, and also the bearing of y from z. Now the first thing we do is we sketch the diagram. And if you look at the question carefully, we notice that the two bearings, they are taken from point x. So we draw our cardinal point for x. Now, y, the bearing of y from x is 060. So we have this 060. Then the distance between x and y is 60 kilometers. This is y, and this one is 60 kilometers. While this one is also 60 degree. That's the first thing A. Now, the bearing of z from x is 290. We also take it from the North Pole. That is from 0 degree. We have 90, 180, 270, then 290. You can see that the line I'm using to represent xz is longer than the line I used to represent xy because 100 is more than 60. So this is z, and this one is 100 kilometers. The angle from here to this line, everything like this is 290 degree. Then I will join this. We need to be very careful with the line we use to represent our bearing. From here, the second question is asking us for the bearing of y from z. If we fail to use the normal line, if we fail to, from here, if you are using the same length that we use for 60 kilometers for 100 kilometers, we will not know that there is a small angle A. I'm talking about this angle A. We have an angle A, but if you should use the same measurement, if you should use the same line, same length of line to represent that, this angle will not show. So from there, we need to get the angle A. Let me call it angle alpha. From there, alpha, we know by the time we complete a circle, that means you have completed 360. But here we've not completed that circle, we still have a particular angle to complete that cycle. So we have alpha plus this one, 290 degree, is equal to 360 degree. Then alpha from there is 360 degree minus 290 degree. Then by subtracting that, alpha is 70 degree. So which means this angle is 70 degree. And if you look at this angle, which is 70 degree, from that z angle that I explained earlier, I said angle like this, we call them alternate angles. So for this place to be 70 now, then this angle outside is also 70. As this angle A is 60, if you also apply that z angle, this angle A is also 60. That is what we call alternate angles. And there is a theorem that says alternate angles are equal. So that's why as this one is 60, this one is 60. As this one is 70, this one too is 70. Now, another thing, this angle here that is outside, this one from this line to this line, the angle there is the same as the angle that we take from this line that is representing eastern direction to this line, but we don't need that. So we are not going to calculate that, but we are still going to be in need of the angle inside this triangle to get the second question, which is talking about the bearing of y from A. Bearing of y will be taken from Z. Now you may ask yourself this question, that do I need to measure this line? But you don't need to measure it. What you just need to do is, there should be difference between the line that, just draw it to any scale, but the line that you are using to represent 60 should be shorter than the line you are using to represent 100. If you should use the same line, though you may end up getting the first part, which is talking about the distance, but to get the second part, which is asking us for the bearing of y from Z, there will be problem, and you may not even get the right answer, because some angles that are hidden that you're supposed to bring out from the line that you use to represent the distance, the two distances that we are given, those angles will not show, and you don't know that those angles occur. So that will affect the solution to the second question. So from here we have angle x, we have that as angle y x z. The 3 is talking about the triangle, but the one that we are laying emphasis on is the one at the middle, which is angle x, and that is 60 degree plus 70 degree, which is 130 degree. So after that, the next thing we do is to state the rule we are using cosine rule. We have the one, since we are to find x, we have x squared equals y squared plus z squared minus 2yz cos x. So by substituting, we have the value of y from there is 100 the square plus 60 square minus 2 into 100 multiplied by 60, then cos 130 degree. And if you look at 130 that we have here, it is coming from second quadrant. And from the second quadrant, cosine is not positive, it is negative. From second quadrant, it is only sine that is positive. Cosine and tangent are negative. So from there we have x squared to be 10,000 plus 3,600 minus 2 into 6,000. Then this one will be minus cos 180 degree minus 130 degree. So from there, this one we have x squared to be 13,600 minus 12,000 into minus cos 50 degree. And from there we have 13,600 minus 12,000 into, if you check our four figure table for cos 50, we have that as minus 0.6428. Then we have x squared to be 13,600 minus, multiplied by minus will give us plus. Then the product of these two will give us 7,713.6. So by adding these two, we have x squared to be 21,313.6. And when you get to this stage, the next thing to do is to find the square, to take the square of both sides, since the expression involves is involving square. So take the square root of both sides. We have this as square root of x squared equals square root of 21,313.6. Then from there, x is 145.99 kilometers. But because the other ones, they are to the nearest whole number, we have yz, which is what the question is asking us first, as 146 kilometers. This is 9. So by the time we round up 9, it will become 1. And the addition of that one with 145 is giving us 146 kilometers. And that will take us to the second part. And the second part is asking us for the bearing of y from z. So what we do there is we need to get what the value of this angle is. And after getting that angle, we now remove the value of this one plus this one from 180 degrees. And that will give us the bearing of y from z. The bearing of y from z is the angular measurement from the north pole to the line that is connecting y to z. This is the line that connects y and z. So we have to get the angle from the north pole to this place, taking it clockwise. So we have, using cosine rule, we have cos z is equal to x squared plus y squared minus z squared divided by 2xy. So by substituting, from there we have cos z, x from there is 146 square, and y is 100 square, z is 60 square divided by 146 multiplied by 100. Taking the square of 146, we have cos z to be 21,316 plus 10,000 minus 3,600 divided by 29,200. So by simplifying the denominator, we have the addition of this and subtraction of that one as 27,716 minus 29,200. So if you divide, we have cos z to be 0.9492. And when we get to this stage, the next thing to do is to take arc cos of what we have here to be able to generate angle z. So we have z to be arc cos of 0.9492. And the next thing is to go to our four-figure table under cosine of angles. I will check for the nearest value that will produce this, and that is 18 under 3 difference 5. That is what z is. Z is 18.35 degree. That is just the value of this angle here, 0.35 degree. This angle. But I said something earlier that the bearing of y from z is the angular measurement. We have to take the angle from this north pole to the line that connects y and z together. But from here, taking it from here to the south pole, we have a straight line. And angle on a straight line is 180. So to get this, we just add these two and remove it from 180. That is what will give us this angle that we have left. So therefore, bearing of y from z, that will be 180 degree minus 70 degree plus 18.35 degree, and that is 180 degree minus 88.35 degree, which is 091.65 degree, and we can round it up as 0.92 degree.